Hi guys, I wanted to make this video today to help you guys out with science. So remember yesterday we have been talking about forces. We've been talking about contact forces specifically. And yesterday we started talking about net force and how to calculate net force, okay? Remember we calculate net force by using subtraction. We subtract the two net forces and then that gives us our total net force. And then it is going in whatever direction more force is being pulled towards, okay? And that's what we looked at yesterday. So today we're going to kind of go back to those ideas of balanced and unbalanced forces, okay? So when we think of the word unbalanced, okay, if something is unbalanced, it's uneven, okay? When we think of the word balanced, it means it's even. It means it's the same. So keep that in mind as we're going through what balanced and unbalanced forces are. All right, I'm going to share my screen here. Make sure you're putting these down in your notes. All right, so first thing in our notes, please, balanced forces. Balanced forces. So balanced forces are two forces equal in size acting in opposing directions on the same object. Go ahead and write that down, please. So when we have balanced forces, okay, it means that the force that is acting on something, it's the same, okay? So yesterday we looked at the example of where you had two forces acting on an object and they were different, okay? So balanced forces is when they're the same. So you have 5 newtons going in this direction, you have 5 newtons going in this direction. So because the forces are balanced and they're the same amount of newtons going in that same direction, when forces of an object are balanced, the object does not move. All right, so when the forces of the object are balanced, it means it does not move. And that makes sense because if I'm pushing something with 3 newtons this way and another person is pushing something with 3 newtons this way, it's balanced and it's not going to be going anywhere. So when forces of an object are balanced, they do not move. Or if they're already moving, it just keeps moving at the same rate of speed. Now, what does that mean for our net force when we calculate our net force? Now, look at this. If we look at this box and each hand is pushing on the box with 5 newtons of force, what is our net force going to be? Well, make sure you're using that formula from yesterday. We have 5 going this way, 5 going this way. Okay, so when we subtract those, 5 minus 5 is 0. So our net force is going to be 0. So anytime you have balanced forces, guys, your net force is always going to be 0. So again, if your forces are balanced, your net force is always going to be 0 because when you subtract those numbers, you're always going to get 0. All right, another example of a balanced force, okay, is normal force, which we talked about. Sorry, I don't know why this is doing this. Which we talked about yesterday, okay, and the day before, okay? So remember, normal force is when something is just sitting on something else stable, okay? So we would call that a balanced force as well because nothing is moving. It's staying still. So our net force must be 0. So when a book lies on a table, the forces on it are balanced. Gravity pulls down on it, but the table pushes up on it. So gravity is pulling it down, the table is pushing up, and our net force is 0, so it is a balanced force. So go ahead and put this down, please. When a book lies on a table, the forces on it are balanced. Gravity pulls down on it, and the table is pushing up on it. So as a result, the book's not moving, and we have a net force of 0. All right, moving on. All right, so again, guys, remember balanced forces. If they're balanced forces, okay, they're not moving, okay? They're staying in one spot, all right, because the net force is 0. Unbalanced forces is when opposing forces are not equal. They're unbalanced. So when you throw a bowling ball, you're applying an unbalanced force on the pins. Okay, so go ahead and put this down, please. Unbalanced forces. If the opposing forces are not equal, they're unbalanced. So for example, all those examples that we looked at yesterday when we were calculating net force, 8 newtons in one direction, 3 newtons in the other, with a net force of 5, that would be an unbalanced force, okay? Because the forces are not equal. So if opposing forces are not equal, then they are unbalanced. All right, so let's answer some of these questions. If a student applies 10 newtons of force to the left side of a box, and another student applies 10 newtons of force to the right side of the box, what's the net force applied to this box going to be? If you said 0 newtons, you are correct. Remember, when we find net force, we subtract the two newtons, and 10 minus 10 is 0. So again, this would be a balanced force, 0 net force. Which of the items would not move? A, B, or C? A, we've got 3 newtons going this way, 10 newtons going this way. B, we got 8 newtons going this way, 4 newtons going this way. 15, we got 15 newtons C, we got 15 newtons going this way, 15 newtons going this way. So which of these is not going to move? If you said C, you are correct, because our net force is going to be 0 because those forces are balanced. 24, which of these represents an unbalanced force? 2 forces push a box, resulting in a net force of 0. A student pushes on a wall and does not move, or you kick a soccer ball into a goal. Which of those is going to be an unbalanced force? Well, the only one of those that motion is happening on is kicking a soccer ball, so it has to be C. Remember, when forces are unbalanced, we're having things moving. If it's balanced, there's no movement and there's 0 net force. 25, which of these involves a balanced force? Okay, so balanced, again, not moving. 2 students push on a car and it speeds up. A book slides to a stop across a table. 2 groups play tug of war and the rope does not move. Which of those is going to be a balanced force? If you said C, you are correct. Both of them must be pulling with the same net force. That's why the rope is not moving. It's staying in one place. All right, guys, so when we get back from spring break, we'll start talking about non-contact forces. So just a reminder, remember, contact forces, things that have to be touching each other. And there's 3 types of contact forces: friction, applied force, and normal force. And balanced forces are when the same amount of force is being applied, our net force is 0, the objects aren't moving. And unbalanced forces is when we have different net forces and the objects are moving. So I hope that this video was helpful, and I'll see you guys later.